Check for armature design. Topic problem. Design the armature winding for a 500 kilowatts 440 volt 375 rpm 8 poles compound generated with the external diameter of 1% and gross length of 0.3 meter and flux per pole of 0.087 Weber. Give the following details of the winding. 1. Number of armature conductors. 2. Number of slots. 3. Number of conductor per slot. 4. Size of the armature conductor. Problem continuation. Questions. 5th point. Dimensions of slots. 16. Resistance of armature winding. 7. Weight of copper used in the armature winding. 8 point. Take voltage drop to be 15 volts. Assume single turn coil with lap winding. Electrical machine design. Armature winding design. Z is equal to number of conductors Z is equal to 60 E into A divided by P by N. E is V plus voltage drop for generator. Voltage drop is equal to 2 to 3% of rated voltage. Approximately we find 15 volt, 2 to 3% of rated voltage. A. Number of parallel parts while depends upon the type of winding. Capital E is equal to V plus voltage drop 440 plus 15 455 volts. Given values P poles is equal to 8 pi flux per pole is equal to 0.087 N. Speed is equal to 375 rpm. A value is number of parallel parts which depends upon the type of winding, that is equal to A proportional to P for lap winding. That is very important. A proportional P for lap winding, that is P value is 8, so capital A value is 8. From obtained values and given values, capital Z is equal to 60 E A divided by P by N. Put record values. Z is equal to 60 into 455 into 8 divided by 8 into 0.087 into 375. That is Z is equal to 837. Area calculated procedure. AC area, that is IA dash divided by del A is equal to 142 divided by 4.75 is equal to 29.8, that is 30 millimeter square. Depth of conductor is equal to 18 millimeter, 1.8 centimeter, that is width of conductor is 1.7 millimeter. Size of conductor is 18 into 1.7, 13.6 millimeter square. Width is equal to 13 divided by 18 is equal to 1.7 millimeter. Size area of conductor is 18 into 1.7 is equal to 13.6 millimeter square. That is procedure per area calculator. Solution. Tau S is equal to pi d divided by S. S is equal to pi d divided by tau p. Put in these values. D is equal to 1.1 into 100 divided by tau p is equal to 2.5. S is equal to 138.2. We obtain S value, 138 slots. Third, number of conductors per slot. Z divided by S is equal to 836 divided by 138 is equal to 6.05. That is 6 conductors per slot. Fourth, IL is equal to 589 per 3 divided by 440 is equal to 1136 ampere. IA is equal to 1136 divided by 8 is equal to 142 ampere. IA is equal to IL plus IF, that is formula. IF is neglected. IA plus IL is equal to 1136 plus 142. IF is neglected. Slot loading. Ampere conductor slot into conductor per slot. 142 into 6 is equal to 852, that is less than 1500 ampere. This condition is satisfied. Assume del A is equal to 4.75 ampere per millimeter square. Select between 4 to 6. AC equal to IA dash divided by del A. 142 divided by 4.75 is equal to 29.8, approximately 30 millimeter square. Area of cross section AC. As the area cross section is greater than 10 millimeter square, we are going for rectangular conductor. Depth of conductor less than or equal to 2 centimeter. Frequency is equal to 25 Hz. Depth is equal to 1.8 centimeter, 18 millimeter. That is width is equal to 30 divided by 18 is equal to 1.7 millimeter. Assume depth is equal to 1.8 centimeter is equal to 18 millimeter. Width is equal to 30 divided by 18 is equal to 1.7 millimeter. Depth is equal to 18 millimeter, width is equal to 1.7 millimeter. Therefore, the size of the base conductor is where conductor is 18 into 1.7 is equal to 30.6 millimeters square. Assume thickness of insulation is 0.4. Size of insulation conductor is 78.4 divided by 2.1. Size of insulation conductor is 78.4 divided by 2.1.